The Structure of Scientific Revolutions, by Thomas S. Kuhn. Introduction. I want you to imagine something for a moment. You're sitting in a quiet room, taking part in a simple psychology experiment. A researcher is going to flash a series of playing cards in front of you, just for a split second, and your job is to name the card you see. Simple enough. The first card flashes. 4 of hearts, you say. Correct. Another one. 10 of clubs. Correct again. This is easy. Then another card appears. You see it for just an instant, but you know what it is. 6 of spades, you say confidently. But the researcher doesn't say anything. He just flashes it again, a little longer this time. You look again. 6 of spades, but something feels off. There's a flicker of wrongness. You can't quite put your finger on it. He flashes it a third time, for a full second. And that's when your world tilts on its axis. The card is a 6 of spades, all right. But it's red. A red 6 of spades. Your mind races. You've seen thousands of playing cards in your life. Spades are black. Hearts are red. That's not a rule you think about. It's just how the world is. For a moment, you're in a state of pure confusion. One person in the actual experiment, after seeing a few of these impossible cards, cried out in genuine distress, "I can't make the suit out, whatever it is. I'm not even sure now what a spade looks like." My God! What you just experienced, in that moment of profound disorientation, is the heart of one of the most important books of the 20th century, The Structure of Scientific Revolutions by Thomas S. Kuhn. Published back in 1962, this isn't your typical bestseller. It began its life as a monograph for an academic encyclopedia. Kuhn himself was a physicist who had fallen in love with the history of science, and he thought he was just writing for a small circle of fellow historians and philosophers. But the book caught fire. It has since sold well over 1 million copies and has been translated into dozens of languages. Words he introduced, like paradigm and paradigm shift, have broken out of the university and are now used by everyone from CEOs to sports commentators. Why? Because this book tells a secret about how the world truly changes. It dismantles a story we've all been told since we were kids, the story of progress as a slow, steady, inevitable march toward the truth. Kuhn shows us that's not how it works. Not in science, and perhaps not in life either. By the end of our time together today, you're going to understand this secret. You will see that the greatest breakthroughs in human history didn't happen because someone added a new brick to the wall of knowledge. They happened because someone had the courage to see a red 6 of spades, to acknowledge that the world wasn't what they thought it was, and to tear the whole wall down and start over. This isn't just a story about science, it's a blueprint for revolution. Book summary. We all have a picture in our heads of how science works. It's a comforting image, really. We imagine a grand library of human knowledge, stretching back for centuries. Each generation of brilliant scientists, Aristotle, Galileo, Newton, Einstein, walks into this library, finds an empty shelf, and adds a new book of facts. They are patiently, diligently, building the most complete collection of truths the world has ever known. Each new discovery is a brick placed carefully on top of the last, building a solid, unshakable tower of progress that reaches ever closer to the sky, to ultimate truth. It's a beautiful story. And according to Thomas Kuhn, it's almost entirely wrong. Kuhn, having trained as a physicist, was deeply embedded in the world of science. He understood its power and its rigor. But when he started teaching the history of science to non-scientists, he had a startling realization. When he read the scientific texts of the past, say, the writings of Aristotle on physics, He found they weren't just wrong in the way a modern textbook would be. They weren't just missing a few facts. They were describing a completely different universe, with different rules, different questions, and a different idea of what a good answer even looked like. It was like trying to understand baseball by using the rules of basketball. The players were on a field, they were competing, but the entire game was different. This puzzled him deeply. If science was just a steady accumulation of facts, how could the past look so alien? This question led him on a journey that would eventually reshape our entire understanding of progress. He started by giving a name to the game that scientists play most of the time. He called it normal science. Now, the term normal might sound a little boring, but this is where almost all the work of science gets done. Normal science, Kuhn says, is not about making groundbreaking discoveries. It's not about challenging the foundations of knowledge. In fact, it's the exact opposite. It is, in his famous phrase, puzzle solving. Imagine you're given a massive, 1,000-piece jigsaw puzzle. You have the box, and on the cover is a beautiful picture of a mountain landscape. You have two crucial guarantees before you even begin. First, that a solution exists, the picture can be completed. And second, you know, in broad strokes, what the final result will look like. Your job isn't to create a new picture. It's to use your ingenuity, your skill, and your patience to make the pieces fit into the pre-existing image. That box top, that shared picture, is what Kuhn calls a paradigm. A paradigm is so much more than just a theory. It's an entire worldview that a community of scientists shares. It includes the accepted laws, like Newton's $F equals ma $. It includes the standard ways of applying those laws. It includes the instruments you're supposed to use and how you're supposed to use them. It even includes the unwritten rules about what questions are worth asking and what would be considered a legitimate answer. For centuries, the paradigm for astronomers was the Ptolemaic system, which placed the Earth at the center of the universe. For astronomers working within that paradigm, their job wasn't to ask, is the Earth really at the center? That was a given. Their job was to solve puzzles. They had to explain the strange looping motions of the planets by adding clever little circles, called epicycles, to their models. It was incredibly complex and challenging work. They were fitting the pieces into the picture on the box, the Earth-centered cosmos. And this is the genius of normal science. Because everyone in the community agrees on the fundamentals, they can pour all their energy into the details. They can build incredibly precise instruments and perform mind-bogglingly complex calculations to solve puzzles that would be unimaginable without that shared foundation. They push the paradigm to its absolute limits, extending its reach and refining its accuracy. Normal science is a fantastically efficient machine for producing knowledge within the rules of the game. It's cumulative, just like the old story of progress. It adds new facts and solutions to the existing framework. But, and this is the crucial twist, in the process of all that intense puzzle solving, something strange inevitably happens. A piece turns up that just doesn't fit. You try it one way. It doesn't work. You turn it. Still no. You check the picture on the box, and according to that picture, this piece should fit right here. But it doesn't. You assume you've made a mistake. You're the puzzle solver, not the puzzle maker. The fault must be yours. So you, and maybe your colleagues, try for years, even decades, to force that piece into place. This stubborn, ill-fitting puzzle piece is what Kuhn calls an anomaly. An anomaly isn't just a minor error or an unsolved problem. Normal science is full of those. An anomaly is a deep and persistent violation of what the paradigm leads you to expect. It's a glitch in the matrix. Let's go back to that Ptolemaic model of the universe. For all its brilliance, it had anomalies. The predictions of where planets should be never quite matched the best observations. For centuries, astronomers treated these as puzzles. They'd add a new epicycle here, tweak a calculation there, trying to make the pieces fit. But over time, the model became monstrously complex. It was covered in ad hoc fixes, like a car held together with duct tape. An astronomer in the 13th century, Alfonso X, famously joked that if he had been present at the creation, he would have given God good advice on a simpler design for the universe. The awareness of anomaly begins to grow. The puzzle-solving machinery of normal science, which is so good at refining the paradigm, is also incredibly effective at finding its breaking points. By knowing exactly what to expect, scientists are the first to recognize when nature refuses to play by the rules. This is when the mood begins to shift. A few anomalies can be ignored or set aside for future scientists with better tools. But when they start to pile up, when they strike at the very heart of the paradigm, the community's confidence begins to fray. The once solid rules of the game become blurry. Different scientists propose different, competing versions of the paradigm to try to account for the anomalies. The discipline enters what Kuhn calls a state of crisis. During a period of crisis, the science starts to look less like normal puzzle solving and more like the freewheeling, chaotic period that existed before a paradigm was ever established. Scientists begin to have philosophical debates about the fundamentals of their field, something they would never do in times of peace. They start to express deep professional insecurity. It's a time of immense anxiety, but also of immense opportunity. This is the moment Wolfgang Pauli, one of the giants of 20th century physics, was living through just before the quantum revolution. He wrote to a friend, "At the moment physics is again terribly confused. In any case, it is too difficult for me, and I wish I had been a movie comedian or something of the sort and had never heard of physics." He felt the ground shifting beneath his feet. The old map no longer worked, and a new one had not yet been drawn. It is out of this fertile chaos that something radically new can finally emerge. Someone? Often, Kuhn notes, someone very young or very new to the field, someone less committed to the old ways of seeing, proposes a completely different way of looking at the world. A new paradigm. This is not an extension of the old one. It's not just adding a new room to the old house. It is a complete demolition and reconstruction. This is the moment of scientific revolution. Copernicus, living in the midst of the crisis in Ptolemaic astronomy, didn't just add another epicycle. He proposed a revolutionary, almost heretical idea. What if the Earth isn't the center of the universe? What if the Sun is? This act of switching the center point seems simple, but it changed everything. It wasn't just a new fact, it was a new way of seeing the entire cosmos. Kuhn argues that this transition, this paradigm shift, is not a logical, step-by-step process. You can't prove the new paradigm is better using the rules of the old one, because the new paradigm throws out those very rules. The two paradigms are, in his famous term, incommensurable. They are not just different, they are different kinds of different. They are judging the universe by different standards. To a follower of Ptolemy, the idea of a moving Earth was not just wrong, it was absurd. Part of what the very word Earth meant was fixed, unmoving center. To ask if the Earth moved was like asking if a circle could be a square. It was a contradiction in terms. Furthermore, the old paradigm could point to all sorts of proofs. If the Earth were hurtling through space, wouldn't we all feel a tremendous wind? Wouldn't objects thrown in the air be left behind? From within the old paradigm, these were perfectly sensible, powerful arguments. The new Copernican paradigm had to redefine what words like Earth and motion even meant. It had to create a new conceptual framework. Kuhn compares this shift to a Gestalt switch. You know those optical illusions where you can see either a duck or a rabbit in the same set of lines? You can see one, and then you can flip your perception and see the other. But you can't see both at the same time. And once you flip, the world looks different. After Copernicus, astronomers were still looking at the same sky, the same points of light. But they weren't seeing the same things. Where they once saw a planet, the sun, they now saw a star. Where they once saw a celestial body that simply orbited the Earth, the moon, they now saw a satellite. For centuries, Western astronomers, following Aristotle, believed the heavens were perfect and unchanging. But in the half-century after Copernicus proposed his new paradigm, they suddenly started seeing change everywhere: new stars, supernovas, sunspots, comets that passed through the supposedly solid celestial spheres. The Chinese, whose cosmology didn't forbid celestial change, had been recording these things for centuries. Western astronomers only started seeing them when their paradigm allowed them to. Kuhn puts it in a phrase that has shocked and fascinated people for over half a century: after a revolution, scientists work in a different world. Think about Galileo looking at a swinging chandelier. An Aristotelian, looking at the same object, would have seen something very different. For him, a heavy object's nature is to seek its natural resting place at the center of the universe. The swinging bob was simply a body falling with difficulty. It was being constrained by the chain, so its motion was a tortured, complex path toward its final state, rest. The questions an Aristotelian might ask would be, how heavy is it, how far does it have to fall, and how long does it take to finally stop? But Galileo, trained in a later tradition that included the idea of impetus, saw something else entirely. He didn't see a body struggling to stop, he saw a body trying to repeat its motion, a beautiful, symmetrical oscillation that would, in a perfect world, continue forever. He saw a pendulum. And because he saw a pendulum, he started asking different questions. He measured the length of the chain and the time of each swing. He discovered the pendulum's period, its rhythmic pulse. He saw a simple, elegant regularity where the Aristotelians saw only a complex, impeded fall. They weren't just interpreting the same data differently. They were seeing different data. The very things they chose to measure, the relevant facts, were different because their paradigms were different. They practiced their trades in different worlds. This is the deepest meaning of incommensurability. The debate between paradigms can't be settled by logic or experiment alone, because the two sides disagree on what counts as a good experiment, a valid question, or even a real problem. Each paradigm seems to solve the problems it defines as important, while highlighting the failures of its rival. Proponents of the old and new paradigms are talking through each other, using the same words but meaning different things. So how does a new paradigm ever win? Kuhn's answer is deeply human. It's not a matter of cold, hard proof. It's a matter of persuasion and faith. The new paradigm usually wins because it can solve the one or two anomalies that brought the old paradigm to a state of crisis. This is its key selling point. But at the beginning, the new paradigm is often clumsy and incomplete. It has solved a few big problems, but it has created many new ones, and it can't yet explain all the things the old paradigm could. When Copernicus first proposed his system, it wasn't actually more accurate than Ptolemy's. It was just, to some, more aesthetically pleasing, more neat. Choosing a new paradigm is a leap of faith. It's a bet on future promise, not on past achievement. That's why revolutions are often led by the young. They have less to lose and are less invested in the old way of seeing. Max Planck, another founder of quantum mechanics, put it bluntly: a new scientific truth does not triumph by convincing its opponents and making them see the light, but rather because its opponents eventually die, and a new generation grows up that is familiar with it. It's a slow, generational shift. At first, only a few pioneers adopt the new view. They work on it, develop it, and show what it can do. They make it more powerful, more precise. They begin to solve more and more puzzles with it, Slowly, more scientists are converted, like a gradual shift in the distribution of professional allegiances. Eventually, a tipping point is reached, and the new paradigm becomes the new normal. And then, the most remarkable thing happens. The revolution is written out of the history books. The new textbooks are written from the perspective of the new paradigm. They present the new way of seeing the world as the one, true way. The history of the science is reconstructed to look like a straight, linear path leading directly to the present. Galileo is presented as if he were just a more modern Newton, discovering laws that Newton would later perfect. The messy, chaotic, revolutionary struggle is smoothed over, made to look like the logical, inevitable next step. The revolution, in a sense, becomes invisible. This brings us to the final, profound question. If science isn't a march toward one ultimate truth, then what is progress? Is it just an illusion? Kuhn says no. Progress is real, but we've been thinking about it in the wrong way. We imagine progress as evolution toward some predetermined, perfect end goal, like a perfect representation of what nature is really like. Kuhn suggests we should think of it like Darwinian evolution. Darwin's theory of natural selection was so shocking because it didn't have a goal. There was no grand plan for evolution to produce humanity. Instead, it was simply a process of change driven by survival in a given environment. It's evolution from what exists, not toward what is destined to be. Organisms become better and better adapted to solving the problems of their particular niche. Scientific progress is the same. The process of revolution is a selection by conflict. The paradigm that is fittest, the one that is best at solving the puzzles that the community finds most pressing, is the one that survives. We don't get closer and closer to some ultimate truth about what is really there. Einstein's universe, with its curved space-time, isn't necessarily a truer picture of reality than Newton's, with its absolute space and gravity acting at a distance. In some ways, Kuhn notes, Einstein's view is actually closer to Aristotle's than to Newton's. But it is, without a doubt, a better tool. It's a better instrument for solving the puzzles of modern physics, from the motion of Mercury to the existence of black holes. Each paradigm shift equips the scientific community with a more powerful and precise tool for puzzle solving within its new environment. The puzzles change, the world changes, but the ability to solve them gets better and better. Progress, then, is not about getting closer to the truth. It's about getting better at the game. And this, Kuhn suggests, is why science is so uniquely powerful. It has developed a social structure, this cycle of tradition-bound normal science punctuated by revolutionary breaks, that is a supremely efficient mechanism for doing just that. It creates a community that can work with incredible focus and then, when necessary, has the capacity to tear everything down and start anew, equipped with an even more powerful way of seeing. The story of science is not a quiet, steady climb. It is a series of explosive, world-changing revolutions, separated by long periods of peaceful, focused work. It's a story of seeing, and then learning to see again. It is, at its heart, the story of the Red Six of Spades. Commentary. When you first encounter the ideas in the structure of scientific revolutions, it can feel a little unsettling. The thought that science doesn't march steadily towards a final, objective truth can feel like losing your footing. It seems to open the door to the idea that anything goes, that one theory is just as good as another. But that's not what Kuhn is saying at all. What's so powerful about this book, and why it has resonated so far beyond the history of science, is that it gives us a much more honest, more human, and ultimately more useful picture of how real change happens. It's not clean. It's not logical. It's a messy, passionate, and deeply courageous struggle to see the world in a new way. And this lesson is incredibly relevant for you, right now. Because you have paradigms, too. We all do. You have a set of core beliefs, assumptions, and models about how the world works, how people behave, and, most importantly, who you are and what you're capable of. This personal paradigm is your box top. It shapes what you see, what you believe is possible, and the kinds of puzzles you think are worth solving in your own life. For the most part, this is a good thing. Your paradigm allows you to navigate the world without having to question every single thing from first principles every morning. It lets you get on with the normal science of your life, going to school, making friends, learning a skill. But what happens when you encounter an anomaly? What happens when you work as hard as you can, follow all the rules you've been given, but you don't get the results you expect? What happens when a relationship fails, a project at school falls flat, or you feel a persistent sense of unhappiness, even when everything on the surface seems fine? These are your anomalies. And the typical response is to assume the fault is yours. You think, I must not have worked hard enough, or I'm just not good enough. You try to force the puzzle piece to fit into the picture of the world you've been given. Kuhn's work offers a different path. It gives you permission to consider that maybe the problem isn't you. Maybe the problem is the box top. Maybe the paradigm itself is what needs to change. The moment of crisis in your own life, that period of confusion, anxiety, and feeling lost, might not be a sign of failure. It might be the necessary prelude to a revolution. It's the ground softening, preparing for a breakthrough. So, how can you apply this powerful idea? Here are a couple of thoughts. First, learn to recognize your own personal anomalies. Pay attention to the areas of your life where there is persistent friction, where your expectations are constantly being violated. Don't dismiss these as mere mistakes. Get curious about them. These are the clues that point to the limits of your current worldview. They are the red sixes of spades in your own life. Second, have the courage to question the rules of the game. The paradigms we inherit from our family, our culture, and our education are powerful, but they are not absolute truth. They are just one way of seeing. The greatest innovators, in any field, are the ones who can step outside the current paradigm and ask, what if we played a different game entirely? When you feel stuck, don't just ask, how can I try harder? Ask, what are the hidden assumptions I'm making right now? What if the opposite were true? Finally, understand that real change is a leap of faith. It's a shift in identity. Just as a scientist has to learn to see a pendulum instead of a falling stone, you might need to learn to see yourself not as someone who is bad at math, but as someone who is learning. Not as someone who is shy, but as someone who is thoughtful. This isn't just positive thinking, it's a change in the very data you collect about yourself. When you change your paradigm about who you are, you start to see evidence that confirms it everywhere. You start to live in a different world. That was a deep dive into the structure of scientific revolutions by Thomas Kuhn. We've explored the core cycle of how science, and maybe progress itself, truly happens. But listening to a summary is like looking at a map of a beautiful country. It can show you the layout, point you to the highlights, but it can never replace the experience of actually walking the terrain yourself. The real power of this book is in wrestling with its ideas, in letting its challenging perspective sink in and change the way you see things. If you felt a spark of curiosity today, if you've started to see the paradigms and anomalies in your own world, then I wholeheartedly encourage you to pick up a copy. Reading it isn't just an intellectual exercise, it's an invitation to see the world with new eyes, and that's an experience that can fundamentally alter the course of your life. You can find a link to the book in the description below. And if you found this journey valuable, please show some love by hitting that like button and subscribing to the channel. That way, you won't miss our next exploration into another one of the transformative books that have shaped the minds of the world's most successful people. Let's keep questioning, keep learning, and keep growing together.